Hey everyone, welcome back to my channel. Hope you all are doing great. In last video we saw what exactly the RAG is and what was the problem in LLM, the limitation, and we are using the RAG and all its like architecture, how the vector database, what exactly it is, and just kind of like high level we saw. In today's video we like do a end-to-end coding using LangChain and a different model like Grok will use, and embedding will use a open source embedding from Hugging Face, and we'll see all these component this load document and everything we'll see. If you have not seen that video, I'll recommend please watch that video first so that you will have some understanding about what exactly the RAG is and why we are using that. So let's start, and we'll do step by step all these component, and we'll do the coding end to end. So let's understand these steps, and we will create a basic RAG by using our custom dataset, like our private dataset. We'll use a company data, like a dummy data will create, and we'll use that in order to create a RAG. So what we will understand? First we will understand load document. How can we load a document? Then split. How can we split that document? Generate embeddings. How can we generate the embeddings? How, like what are the different types of like generating embedding models and all? Then where we will store the embedding, and what others vector database we can use to store our embeddings. Then we will take the user query and we'll embed that user query, and we'll retrieve the document from the vector database. Then we'll pass this document and query to a LLM, and we'll generate the answer. So this is how it looks like. Welcome to Soumya AI Vision, and these are our mission, vision, mission, our core values, code of conduct, working hours, flexibility, leave and time of policy. These are, suppose imagine just a company policy and all. So as per our steps, one, load document. So what exactly this load document is? So if you'll see this load document, I'm loading this loaders from this LangChain community. So if you'll go to this particular documentation, you will see they are having lots of different type of loader. Like if you'll see this web page loader, web, unstructured, recursive URL, sitemap, okay, PDFs, PyPDF, unstructured, Amazon textrat. So different type of loader present in this website or in LangChain. You can use as per your requirement. Suppose if you have a Excel file to load, you can load that Excel file, PDF, docs file. So simply give the path of your data directory and pass into the PDF loader, this class. Okay, after that what I'm doing, once I loaded the content, then I'm creating a document object of this file. What document object? Document object is basically like it will create a document class with the metadata and the page content. So I'll do loader.load. What it will do, it will create docs. If I'll print that, let me print the 0. So what it is giving? It is giving the metadata. Metadata, like some metadata from where it is created, who created, like page label. Suppose I'll use this page label in order to like sort my content during retrieve. So we will see how can we use this page label, and how many pages are there, page number, total pages. Okay. So these are, and the main thing is page content. If you'll see this from here, from welcome up to flexibility. Uh, if I'll show you this document, let me home, copy path. Okay, so from here, from welcome to flexibility up to this, from the first page, it's stored in my first document. Okay, up to flexibility. This page content is my main information present in this page content, and these are the metadata. I can create the metadata, custom metadata, so that it will help me during search. Okay, so like 4 different page, like 4 different docs I created from this total 4 pages, each page one document I created. Now once this document created, like document loaded and text extracted, if you'll see this, like these are some kind of like print you can do, and you can see what exactly the metadata, what exactly the content present inside this, and this is what the document object looks like. uh, this is present in LangChain core documents, import document, and documents are like it is a list of document object. The page content, what exactly the text here, my original content, then metadata. You can give your key and you can give your value, you know, to like store inside the metadata. So that suppose like they are having a e-commerce website document where information present about sports product, information about like tech product, okay, some kind of like cloth, everything present. So you can create like a metadata called product, and you can give that product type, so that during search you can only focus on that particular type of searching. That particular, suppose you want to search inside the watch, then you can search, you can filter out the product watch, then you can search that name, so that your result will be like your accuracy will improve. This is how we can use the metadata. Then after this, our split into chunk. So what exactly chunk? Now I created 4 different page of document. Now each page having lots of text from here to up to this full text. I want to split this like text into small part, up from here to here, from here to here, okay. Like that I can define a like number, suppose 1000. So it will go to the from here to 1000 text, and it will split the chunk. Now they're having some problem. Suppose from here it will start, and here happen the 1000. Suppose here every 1000 here the 1000 text. Now it will split from here. So that is what character splitter do, okay. But we will use the recursive character splitter. In recursive character splitter, what it will do, it will start from here and it will check some certain character, if it is a dot or if it is a ending the sentence, and it won't split from here, like middle of the sentence or middle of the text, middle of the word, it won't split like that. It will wait, like suppose here having 900 text, 900 character, and here it is having 1000 characters. So it will stop here, it won't go to 1000, it will stop in 900 itself, and it will start from here, okay. And different they are having different type of let me show you. Okay, they are having different type of characters text splitter, as I told, character splitter and recursive character splitter, and they are having other also like HTML and MD, different type of character splitter. So if you will go to this LangChain page, you will see this document character splitter, recursive character splitter, document structure based, semantic meaning, like based on the semantic meaning you can split your document, okay. Like you will understand the context or understand the sentence of the each line, and it will split the document, okay. This everything is as per our requirement. We can split the document. Now once we created the split, let me run this. Now all split. So if you'll see what I have given here, a chunk size is 500 and overlap is 100. What exactly this overlap is? Suppose what I'm giving overlap here, from here it is started, welcome to Soumya AI Vision. Now here it's completed my 500, okay. Now what I'm giving here, overlap size is 100. Now it will take this 100 character from here, okay, and from the next chunk it will start from here and it will go up to 500, from the next again it will take from here, so that the context between this chunk and this chunk would be same. Like in first chunk the same text present up to this 100 chunk 100 overlap present, in the second chunk also same 100 present, so that the context between two chunk would be like match, so that during our context like when we will give pass this context to the LLM, it will understand properly uh, the first chunk is like second chunk is related to the first, so that it won't miss the context. That's why we are giving this overlap. Now we'll simply split the document and we'll pass the whole document which we created during extraction. So you can see the total 14 chunk created, and each chunk have information, metadata information, and page content. You can see from welcome it started up to creativity. Okay, from welcome it started up to collaboration and creativity, up to here collaboration and creativity. Let me see where it is. Collaboration and creativity, up to this it created my first chunk. In the next second chunk where it is starting, if you will see the page content, our mission, and here also our mission is present, and here also you can see our mission up to it is going to guidelines. Okay, the first chunk up to here, up to this it started. In the second chunk our mission from here it again it started. Similarly it will continue up to last. Now once my chunk is created, now each chunk I have to create the embedding. So this is a open source embedding from the Hugging Face. You can simply go to the Hugging Face and search this name and you can directly use it. Okay, you can directly use this. You can pass something like some text and you can test here your embedding and all. They're having different type of model like large, base, small, and different size also, dimension size also. I am using the small one, but you can use the different one like 1024 also is there, but I am using 384. So you can use the LangChain community.embedding, and you can use this Hugging Face embeddings. If you will see what different type of embedding present, so simply go to this embedding documentation. So lots of different type of embedding present in whatever like in market like embedding present, everything like all the integration present inside the LangChain. So you can directly use that model name and the model keywords like the device what you are using. Right now I'm using the CPU, so you can use that and you can directly run this. So it will download the model from the Hugging Face to your collab or to your laptop. Then after that you can create the embedding. The vector one, like this is how you can create the embedding one, text by text or page content, like simply embeddings dot embed query. This is a method. You can pass the text and it will create the embedding for you. Now you can check whether the embedding is similar or not. This is how you can check. This is just example, but in real time we are not checking like this, or we are not will not create the embedding like this. How we will create? We'll just store the embeddings, we'll create and we'll store in a vector database. So for that we are using a face vector database. So if I'll show you how many different types of vector database in LangChain, simply vector database LangChain, just search. So there are like different type of Azure, Olama, Mistral AI, Nvidia, okay, Bedrock. So lots of vector database present in market. They are having some like advantages, disadvantages, as per your requirement you can use. So these are the like mostly like for development or some kind of like POC you can use this face and chroma. Okay, these are like open source models, and you can use this chroma db and face. Okay, after so here what we are doing, we are creating a web face object, and we are passing the embeddings model. This embedding model what we have created here, this embedding model we are passing here, and a in memory doc store. In memory doc store is basically like it will store your document just for current instance. It will create some id and it will store in the document, so that it will help for the fast search. Okay, and so here we are giving the dimension size. For dimension size, this is just creating a embedding query, so that it will give the length of the embedding. So length is basically, so if I'll run this 384 it will give, yeah, 384. And I'm giving just embedding size. You can give just like, don't confuse about this hello world, you can give anything to this embedding. Now once this vector store object is created, now you have to like add your all your document to this vector store. What document? The splitted document. In the above what we have splitted the document, this all split document, 14 total 14 document you have to pass to the vector store. So what it will do, it will create the embedding of each chunk and it will store in the vector store, and it will provide you the id. Let me run first this and this. So it will create all the vector store and it will give you the id. Let me search the ids. So these are the ids for each chunk. Okay, now if I'll search simply, so how can you search? Simply vector store dot similarity search. If you inside similarity search, you can pass the query and k. Top k is basically like the top score. Suppose whenever I will perform the similarity search between the my question and the this vector store embeddings, so it will give me the score. Like it will check this particular text will be checked from like by comparing with this like that, and it will generate some score. So I want the top score, like which is the top 5 score or top 4 score, that I can define inside this k. By default k is 4. I can define this top k here, and they're having some different kind of like filter and all. I can add this metadata filter and all into this similarity search. If I'll run this, so it is what it is saying, it is giving me the chunk. So it is giving me the page content and the metadata. So if you'll see this learning Friday, Fridays, every Friday 1 hour is reserved for self running. Some information is giving annual leave, sick leave, casual leave. So this information it is giving. So why it is giving? It is just performing the similarity search and it is giving. So if you search, I am just giving you I am just used here result of 0. If we'll see the all the result, so they are having so many things will be there. So if you'll see the first id, this one is came. So these are some information about this leave only 6 days per year and all. Then second document, this is the second document, and third document, and then fourth document. So these are the like document came, and you can see the page number also. Now similarly like you can ask like different question, like similarity search with score. Okay, and you can do asynchronous search also. Benefit of this company, if you search this benefit of this company, then what is saying, monthly health checkup and yoga session, no late night work policy, operational wellness. So these are some kind of like similarity searches between, like you can see the score 0.44. So this is our retriever. We can create the retriever by calling as retriever method, and we can pass here the similarity type, like they are having different type of similarity search. We can pass the similarity, cosine similarity we are passing, and the search keywords is keyword argument is k equals to 5. And we can search the batch, like multiple query at a time also we can search. Now the final we'll take a query and we'll generate the final answer by calling to the LLM. You can simply take a query, what is the company's leave policy and what food is available. I'm just simply asking. You can create the embedding of query like this. But whenever we are searching directly into vector database, what it will do, no need to create the embedding and search. It will automatically create the embedding and it will search in the vector database. So these are some information coming. Let me, I have given here 5 top page equal to top k equal to 5. It is giving some page content. Page content is learning Fridays, every Fridays 1 hour, some details, then casual leave. All this information is coming in the context. These are my context. Now I retrieved. Now I will take this content and I will give to the LLM, so that LLM will understand this content and it will generate my answer based on the query. So what I will do, I will pass this content to the LLM, my query and prompt. How can I pass? Let's see. Now first I will format this text, because these text are not proper, like these are page document and the text metadata and all, like I don't want to pass everything. I'll pass the page content only to the LLM. So what I'll do, I'll create a page content like a sorted document, so that page content will be in here if you'll see. So here the page number 1, like page number 2, page number page 2, page 3, page 2, like that it is coming. So if I'll like add this text, I'll just concatenate this text, the format will be like change, like the second one will be come last, the third one will come first, like that. So I want to sort based on this page, from which page this is coming, so that it will be proper. So that's why I'm creating this sorted. If I'll sort this, and you can see the page last 3 is last and page 2 is coming before page 3 and page 1, and this is page 1. Okay, now I'll join all those document doc dot page content for doc in sorted document. So I'll take only the document page content document and I'll add, like I'll just give 2 enter and I'll add. These are the my documents. So here you will see learning Fridays and from up to this, and casual leaves, employees wellness, mental health. So these are some information now I got. Now if I'll pass all these information to LLM will understand this information. Instead of, so what I was doing earlier, I was thinking to pass full document, full 4 page of document to LLM in order to give me the answer. But right now, from the 4 page of document, I retrieved only this document, this many text. Now my text size is less, my cost will be like less, my input cost will be less, output cost also will be less. Now I'll initialize a LLM. So for that I'm using a LLM Grok LLM. So this is the API how you can create this Grok LLM. Let me show you. Just simply go to search Grok API key and you log in with your Gmail account. Okay, Gmail account, and simply click on this APIs key and you can create a API key for you. This is my API key. You can, this is free, don't use my API key because they are having some limit per month you have to use. You can create your own API key and you can use that. Like chat graph, you can pass your API key, and the model I'm using Llama 3.18 billion instant, and temperature you can pass anything like as per your requirement, or if you want to generate answer constant, like correct answer, you can define 0. If you want to like variation in answer, or like kind of like uniqueness in answer, or kind of like random answer, you can generate like modify the temperature also. And then full prompt I am writing here: based on the following document, answer the question below. The simple prompt you can define as per your requirement. Then document I'm passing here combined document. What I received here, this is my combined document. This combined document I'm passing here, and query. So if I'll run this and I'll see full prompt, let me print it. Print. So you can see this is the document, and in the question, like what are the company's leave policy and what food is available, I'm asking. Now I'll ask this thing to my LLM. So how I'll ask, I'll simply say model, which I created in top, this model dot invoke full prompt. Okay, so if I'll just write AI message dot content, let me first write AI message, how it looks like, so that you'll get some idea. This is AI message, object is creating content, and if you see here, response metadata, token uses, completion token, how much token it took to complete, prompt token, total token size 662, completion time, how much time it took to complete. Okay, everything you can see here. And if you simply say AI message dot content, what is saying, according to the document, these are the information: annual leave and all, and as for the food available, the company provides free tea, free coffee, healthy snacks at the office. Okay, so this is what you can create a small basic RAG using LangChain. So this is the architecture which I was talking earlier. You can create a basic architecture, not basic, like this is the a RAG proper architecture, and you can implement different thing in this, like evaluation and all. Simply like what here happening, indexing, document is coming, then chunk we are doing. The once chunk is completed, now after that so here we are doing chunking. Then after chunking, then we are doing embedding here. So after embedding we are doing the vectorization. Here we are doing the vectorize, then we are storing in a index, vector index we are storing. After storing in a vector database, then what we are doing now, my this task is constant, like one time task. From here, like indexing document up to this, so the this task is my constant task until my document is changed. Suppose tomorrow my document will change, I have to rerun this phase. Okay, rerun this process, and I'll store again the document. Now the in the real time, what will have happen, the user came and you'll ask some query. Suppose what is my leave policy. Okay, now it will go to the embedding model. Actually not, it's not directly going to embedding model. When we are doing search, embedding model is called, and it will do the embedding and it will search in the vector database. So it will do vectorize for the query, and it will search in the vector database. Mean same time we are passing the query to the LLM also. We are creating the prompt as I discussed. Then from here we are retrieving the text, the final text from the document, from the vector database. We are creating a query. We are formatting a final prompt context, query, the context and the prompt. Then this full document, like full text, we are passing to a LLM. Now LLM is generating the response, and this response we are passing to the user.
Okay, so this is how this RAG is working. If you have any doubt, anything, just comment. I'll answer all of your comment. In the next video, we'll see how we can improve this RAG, or how we can use agentic approach of this RAG. How can create a agentic RAG, so that we'll refine our prompt before passing to a LLM.